Hello, welcome to Monday's edition of Cracking the Cryptic. Now, we tend on the channel to focus on some very beautiful, very intricate puzzles. So the daily fare is often of a reasonably hard standard. Mark and I are conscious of that, and we're not really suggesting we're going to change it, but we are going to try and make sure that we cater for everybody. And there are some people who come to the channel with relatively little Sudoku or logic puzzle experience who want to learn about how to get better. And with that in mind, it's probably not best to start with very detailed Sudokus doing, swordfishes and aligned pair exclusions. So each week I'm going to try and make a video which is designed to cater more for the somebody who wants to improve their Sudoku skills. And this week I'm going to look at the New York Times Sudoku. This is Monday's puzzle. If you want to try it, you can. If it's Monday and you're watching the video, you can go to New York Times website where the puzzle appears free. We're going to look at the hard Sudoku. And if it's not Monday, then click on the link under the video, and that'll take you to our software where you'll be able to try the puzzle. Now, how do we start a puzzle like this? Well, the way we start all Sudokus, really, we are going to have to look for places where numbers or cells are particularly restricted. And on this puzzle, I'm just going to start with the ones, because I can see I can place a 1 in this cell here because of the 1 here, here, and here. Now I'm not going to leave the ones yet, because this one is quite interesting because of the effect it has on this bottom left box. Very important when you're improving your Sudoku skills to get used to using pencil marks. Some people think they're cheating. I don't. I'm not of that school. It's just a different exercise altogether if you're going to try and do Sudoku purely by memory. And I think certainly if you want to get into some of the more advanced techniques, then using pencil marks will really help you. So you can see all I've done here is limit the ones to these two squares, and that's going to allow me to place a 1 into this position, because there's a 1 here, it's a 1 in one of these two squares, and this one over here locks the 1 in this box into this position. And again, over on the right hand side, we can do some pencil marks. I recommend only putting pencil marks in if a number can go in exactly 2 positions, by the way. Don't get into the habit of putting, loads and loads of pencil marks in the grid. We need to keep it as brief as we can, otherwise the grid quickly becomes very cluttered, and it's much more difficult to sort of see the wood for the trees. Now, let's carry on. So let's look at continue to look at 2s, I guess. Can we do anything more with them? I'm not seeing anything good with 2s. Let's move on to 3s. This square here has to be a 3. That's combining this one, and the one down here. Let's move on to 4s. We're going to do it in a fours into these two squares. This must be a 7, look. Just notice that, these two 7s into those positions. And 7s also give us this square as being a 7. Let's carry on. 5s, I don't think we're going to get much further with 5s. I think there's only 1 6 in the grid. I might have miscounted that, but I'm only seeing 1, so 6s are probably not going to be the place where we're going to make lots of progress. We can pencil mark some 8s into those two squares because of this 8, and this 8 in the centre. It's also a real dearth of 9s, isn't there? Got this 9 here. Okay, now here's our first bit of, I suppose, tricky logic. Now, if you look at this 5, you can see that the 5 are therefore locked into one of these two squares in this top left 3x3 block. Now if we come down to this bottom left 3 by 3 block, I don't know much about the 5s, but I do know that they're going to have to appear in column 2 or column 3 because of obviously these 3 cells are already taken. So we've got a 5 in column 2 or column 3 up here, and a 5 in column 2 or column 3 down here. So the 5 obviously is going to have to be in one of these 3 cells in this block. But if we look at row 4 of the grid here, we can find something interesting, because these 2 cells can't take a 5 look. So the 5 in row 4 needs to be in one of these 3 cells. But we've just explained, or I just explained, that the 5 also needs to be in one of these 3 cells. So there's only one cell that matches both of those criteria, and it's this one. So in fact, we're able to place a 5 into that square. Now, does that give us anything more? When we get to the stage where we have 6 numbers in a row or column, I'm definitely going to have a look more closely at this. In fact, I can see we're going to be able to put a number into this square. So if we scan down the column, you can see we're missing the numbers 2, 4 and 9. So let's have a look at these rows. This one obviously doesn't have anything useful. This one has a 2 in it, and this one has a 2 in it. So where can I put a 2 in this column? I can't put one, oops, why is it doing that? I can't put one here, I can't put one here. The only valid square is going to be that one. So let's put the 2 in and see if that tells us anything more about the solve. Obviously these 2 squares now have got to be 4 and 9 in some order. So we should certainly pencil mark that in. 4, 9, 4, 9. And look, we've got 4, 9 here. So now these 2 squares have to be the numbers 4 and 9, because we know there's a 4 and a 9 here, and a 4 and a 9 here. So in this block, I must put 4 and 9 into column 2. And there's only 2 free spaces. So this square must be a 4 or a 9. This square must be a 4 or a 9. Can this square still be a 5? Obviously not. So we remove the 5 here. The 5 must be in this position. There must be a 5 in one of those 2 squares now because of this 5 and this 5. This square is going to be a 6 just to complete the box. And that gives us our second 6 in the grid. And that 6 is, we can actually use these 2 6s together to pencil mark some 6s into this block now. It's not massively helpful, but Sudoku is all about building up patterns. It takes time. You can see these 2 squares now are a 2-3 pair. Now, as you like, you can either pencil mark that in and try and remember it, or try and remember it, I guess. The reason I haven't pencil marked them in is that it disturbs this pencil marking method I'm using, where I'm actually within 3 by 3 blocks. I'm only pencil marking where a number can go in exactly 2 positions. Now, it wouldn't be true to say if I put a 2 and a 3 in here that either of these numbers only goes in 2 positions. That would be confusing. So we've got 2's here, so there must be a 2 in one of those 2 squares. There must be a 6 in one of these 2 squares. So the 6 here, the 6 here, and this 6. What next, you may well ask. Let's have a look. We've got 5 numbers in row 3, so let's just check what we need. We've got 4, 7, 8, 9. So this square can only be a 7 or a 9. No, it's not looking good, is it? I'm not seeing a great deal there. This 4, though, we can pencil mark some 4s into those 2 squares in the central box now, and that is pointing over here, so that's going to give us more numbers. 4 here, 9 here. Now if we look at the effect this 9 has on the central box, where can I put a 9? You can see it's only going to be in this square, 9 and 3. And just checking whether I can see anything particularly useful as a result of that. I think probably let's make sure that we pencil mark 5s into these two squares. This is a 4-5 pair now. You can see that eliminates the possibility of a 5 there, so this is going to have to be the 5. And we've now got a 3-8 pair. Look into these squares. So again, it's going to be something I'm going to just try and remember. And let's check the central row, because this 4-5 pair effectively means we know roughly the position of 6 numbers. So we're just looking for the 1, the 6 and the 8. This can only be a 6 or an 8, but we don't know anything really about 6s and 8s on the whole of the right hand side of the grid. So again, I think we need to step away from that side and think again about where our next number might come from. I'm going to check column 4 because I've got 5 numbers in that. You can see I need 2, 5, 6 and 7. So let's have a look at that square. There's a 2, a 5 and a 6 already in the row there. So this square in fact is what we call a naked single. The only possibility for this square, if I study it, is a 7. Everything else is ruled out. Now there's a few things that we're going to get. That 7 looks really helpful to me. Firstly, let's look at the bottom of the grid. Where can we put a 7 in this box now? Well, it's only going to be there because of this 7 over on that side. And now if we look at these two 7s, we're going to force a 7 into this square because of the 7 down here. Now, as well as putting that 7 in, that 7 just took the place of a pencil mark 2. So I can place the 2 as well. Pencil mark the 2s as a result of that into these two squares. We've now got 7s all around the grid. We're going to be able to place a 7 here as well. And New York Times software, once you complete a digit, it changes the font, which certainly confused me the first time I saw it, but that's what's happened there. Right. So where should we look now? Let's have a look at this square. And the reason I selected this square is I looked at the bottom row and I could see I needed 1, 4, 5 and 8. And I've done a lot of these puzzles over the past, so I'm scanning upwards all the time. You can see I've got 1, 4 and 8 in the column here. So this square can only be a 5. And that's going to give us a 5 there as well. So these two squares now can only be 2 and 6. Not sure about that. 1, 4 and 8 into these squares. You see the 4 here means this is only a 1 or an 8. And this 4 here means this is only a 1 or an 8. So in fact, this square is what we call a hidden single. And the difference between a naked single and a hidden single is if I look at this square on its own and I compare the contents of the column with the contents of the row and the contents of the box, I can't decide actually whether this square here is a 4 or an 8. There's nothing that tells me, just looking at the cell itself, why this cell should only be a 4. It's only by considering the whole of the row and asking where the 4 can go in the whole of the row that we can hone in on the logic that says actually this is the only valid position for 4. So let's put the 4 in, pencil mark 4s into those two squares. That's going to unwind the 4 and the 5 in the middle there, look. We're now going to be able to place a 5 into this square because of the 5s in this position, this position, this position, and this position. And you can see, the moment I put a 5 here, I'm taking the place of a pencil mark. So again, I'm going to be able to go 5, 2, 6. 6 is now point down there, so that's a 6. If we look down this column, we still need an 8 and a 9 into column 5 there, and we have an 8 there, so that's going to give us 8, 9. This has got to be a 2 because it's we need a 2 in this box, obviously. Let's put the 2 in. Now we have 2s here, You can see all of a sudden I think we're starting to get to a position where we're likely to be able to finish relatively quickly from here. Let's keep track of the pencil marks. These two squares are going to be forced, aren't they? This will have to be a 1. Let's put that in. That resolves the 1s there. This one has to be an 8, I think. Let's put that in. Now, where can we put an 8 in this box? With this 8 and this 8, only one position. Place the 8. Place the pencil mark of the 3. Come over here. 8, 6, 2, 3. All sorts of font changing going on, which is obviously a good sign. These two squares have got to be 8 and 9. Why don't we pencil mark them in just to keep track? These two squares have got to be 6 and 9. Well, we can resolve that. These two squares now have to be 4 and 6 pair. Oops, because of this 6 here. So this square obviously now we can fill in anyway. That's got to be a 9. 9's into one of these two squares. This must be an 8 because of the 8 here, the 8 here, and this 8 over on this side. That resolves the 8 and the 9 into those positions. This 9 here then forces a 9 there. That gives us the 4. This has to be a 6. 9, 4, 4, 6. And that's the New York Times hard puzzle. Now, I went through that really, really slowly, but I hope that that is useful to those of you new to the channel. This is the way that, you know, developing the skills necessary to solve a hard Sudoku will lead you on to some of the wonderful, wonderful puzzles we've seen on the channel in recent days. Yesterday's multiple X-wing was, you know, a thing of beauty to me and a joy forever, as Keats might have written. So thanks for watching. We'll be back soon with another edition of Cracking the Cryptic.